Today we did some more practice with circles. So whenever you see the word concentric circles, and you see a picture that has a circle within a circle, like the picture over here, make sure that you always split this into two different circles, okay? That's just a note I'm going to start off with. Let's read the question. The circles at the right are concentric circles that both have point E as their center. Okay, so point E is the center of both of these circles. That's important information. If the measure of angle 1 is 42 degrees, you always put your information in the circle as soon as you get it. Determine the measure in degrees of arc AB. Oh, let's do that in a different color. Of arc AB and CD. Okay, well, let's draw our big circle here and our little circle here. The center is E. The center is E. We are looking for the measure of arc AB and DC. Both of these are 42 degrees. And we know that the measure of the central angle, remember a central angle is an angle that has its vertex at the center, E, which the question tells us both of them have their center at E. And it has two radii as sides. Both of these have radii as their sides. So we know that the measure of arc length AB is 42, and the measure of arc length DC is 42. And that is our answer to this one. Next, we have in circle Q, AC, so AC and BD are diameters. Okay? Find each measure. There's a reason why the problem tells you certain information, right? This problem is telling us that AC and BD are diameters. So that means all of these angles add up to 180. All of these angles add up to 180. All of these angles add up to 180, and all of these angles add up to 180. Okay? So I don't want to confuse you, so I'm going to erase those, but I want you to see that when the problem tells you that something is a diameter, you're probably going to have to find out which angles add up to 180, right? So we know that this angle here, 6x plus 5, this angle here, 5x plus 3, and this angle here, 8x plus 1, all fall into the diameter that AC creates. So we can set all of those equal to 180 because a diameter creates a semicircle. And the angle measure in a semicircle is always 180. Okay, so let's combine our like terms. We have a 6x here, a positive 5x here, a positive 8x here. And that gives us 11x and 8x, 19x. Here we have a positive 5, a positive 3. That gives us 8 plus 1 is 9. Right? We get 19x equals 171 divided by 19, divided by 19. Let me get my calculator real quick. And our answer is 9. X equals 9. So we're finding the measure of each angle, right? So we're finding the measure of this angle. So the measure of angle A, hold on, what letter is that? Okay. The measure of AQE. We're finding the measure of EQD, and we're finding the measure of DQC. Okay? So AQE, 6x plus 5. The figure tells us that the equation is 6x plus 5. Hold on, whoops. 6x plus 5. We know that x equals 9, so let's plug that in. We get 6 times 9 plus 5. 6 times 9 is 54, plus 5 gives us 59. Remember, as soon as you get the angle measure of something in the circle, write it in the picture. Okay? Next, we're finding the angle measure of EQD. So angle EQD is 5x plus 3. We know x is 9. 5 times 9 plus 3 is 45, plus 3 is 48 degrees. 48 degrees. Finally, we have DQC, angle DQC. Angle DQC is 8x plus 1. We know x is 9, so 8 times 9 plus 1. We get 72 plus 1, 73. So here we have 73 degrees. And we're done. Another example. Okay, so we have, it just says find and then a bunch of different angles. So when I get a question like this, I always find that it's easier to just take the info I have, figure out the measure of all the angles, and then just go through and answer all my questions, right? So let's see. I have diameter ML. This is a diameter. So I know that everything in this half of the circle is a semicircle, and that equals 180 degrees. So let's solve for x real quick over there, okay? We have x minus 1 plus 3x plus 5 equals 180. Combine our like terms. We have negative 1, positive 5, and then we have x and a positive 3x. We will get 4x plus 4 equals 180. Minus 4, minus 4. We get 4x equals 176 divided by 4 divided by 4. X equals 44. Okay, so we know that the value of x is 44. So this angle here, angle LCR, angle LCR is 3x plus 5. So let's plug in our value of x, 44. And we get 132 plus 5 equals 137. So we have 137 over here. Hold on, we have 137. Okay. X minus 1 is RCM. We know that x is 44. We have 43 right here. Now this is 60. We know that all of the angles in a circle add up to 360 degrees, right? So if this is 137 right here, this angle is 137, this angle is 43, and this angle is 60, we can add all of these together and subtract it from 360 in order to get the measure of this angle. So that's exactly what we're going to do. We're going to do 137 plus 43 plus 60 plus x, let's call this x, equals 360. Okay, so let's do the math for that real quick. And we get 240 plus x equals 360. Minus 240, minus 240, and we get 120 equals x. So this is going to equal 120 degrees. Okay? So now our circle is completely labeled. So let's go through and see if we can answer any of these questions, okay? So number 1 is asking us to find NCL. NCL is 120. Then it's asking us to find RCL. RCL. We know that RCL is 137. Okay. Next, it asks us to find RCM. RCM is 43. We know that. RCN. RCN. And that is going to equal 43 plus 60, because RCN encompasses both of those pieces. So we get 43 plus 60, and that gives us 103 degrees. The measure of arc NL. NL. Remember, the measure of the arc is always equal to the measure of the central angle. The central angle on NCL is 120, so we know that the measure of the arc length has to be 120 as well. Measure of arc RL. We have RL. RL, the measure of the central angle is 137. The measure of the central angle is always equal to the measure of the arc, so we know that RL is 137 degrees. Now the measure of arc RM. Let's find RM. RM. Oh, well, the measure of the central angle is 43. We know that the measure of the arc length is equal to the measure of the central angle, so the measure of arc RM must be 43 degrees. The measure of arc RN. So this encompasses this angle here and this angle here, so we're just going to add them together. And we get 43 plus 60 equals 103. And we're done. So the main key to success here is that we found all the angle measures and then just answered the question quickly. Now this is the last question that we did for classwork. And it's basically asking you if this were a circle graph, and this is 78%, and this is, oh, let's say this is 10%, this is 8 and 4, 8%, 4%. It's asking us to compare percentage points, I suppose, to the 360 degrees that are in a circle. So we need to set up ratios in order to find how many degrees are in the angle that makes up this percentage piece. Okay? So when we set up a ratio, we want to find the maximum. So 100% of the circle here is going to be 360 degrees, right? Because 100% is the whole thing. If you give 100% of your effort, you're giving all of your effort, right? So 100% is 360 degrees. Let's go to the first one. It gives us 78%. We want to find what is the degree measure of this angle. We don't know what it is. So now we are going to cross multiply, and we get 100x equals 360 times 78. And we get 28,080. Divide both sides by 100. Divide both sides by 100. And we get x equals 280.8. Okay? So you're going to set up the exact same ratio for the rest of the percentages in this column. You're going to set it up 100% is to 360 degrees as whatever percent they give you here. So let's say 10% is to x. Then you cross multiply and you solve to find this number, okay? So I'm going to do the length of the arc one for you right here. So we need to find the maximum first, right? So the equation for circumference, because circumference would be the maximum of the arc lengths, right? It's all the arc lengths added together in a circle where the radius is 10. So first we need to find the maximum. So the maximum circumference is going to be the area around, the distance around the whole circle, right? So let's find the circumference of a circle where the radius is 10. 2 pi r is the equation for circumference. They tell us that the radius is 10, so I'm going to plug that in. And we get c equals 20 pi. 20 pi gives us 62.8. Okay, so this is going to be 62.8. So now we're going to set up the exact same ratio that we set up for degree measures, except this time with the maximum circumference as our 360. Okay, so now we have 100% is to 62.8 is to our maximum as the percentage point given, so 78% is to x. Arc length. Now we cross multiply and we get 100x equals divide both sides by 100. .98. We get 48.98. Okay? And then you would do the same thing for the rest of the percentage points in this column. I'm just going to erase this because I'm out of room, okay? Alright, so in this column, it's asking us for the area of the sector if the radius is 10. So same type of circle, radius is 10, okay? Now we need to find the maximum area, which is going to be pi r squared, the area of the whole circle, right? So pi r squared, they give us r as 10, so this is 100 pi. And we get 314. Okay? So we're going to set up a ratio now where 100% is to the maximum area, which is 314, as whatever percentage they give us up here, as 78% is to x. Cross multiply and put the answer up here.